AI can build an app in minutes. Vibe engineering makes it safe, tested, observable, and ready for production. Let's begin with the prototype is not the product. An AI agent can turn a prompt into a convincing prototype before you finish your coffee. That speed is useful, but a running demo does not prove the app is correct, secure, maintainable, or recoverable. Vibe coding optimizes for momentum, describe the feeling, generate code, and keep prompting until the screen looks right. Vibe engineering keeps that momentum, then adds explicit controls around what the agent may build and how the result earns trust. The difference appears when requirements change, an API fails, a secret is exposed, or a generated patch touches code nobody intended to change. Our example is a support ticket triage app that classifies a ticket, drafts a reply, and can update the help desk system. The goal is not to remove the agent, it is to surround the agent with an engineering system. The goal is not to remove the agent, it is to surround the agent with an engineering system. That sets up the 5-gate production loop. Before code, give the agent a contract, the behavior, boundaries, and acceptance criteria. During execution, expose only the tools and data needed for the current task. Before integration, run deterministic tests and behavior evaluations against known cases. During review, make the patch, evidence, and risk visible to a human owner. After deployment, record what happened and preserve a fast rollback path. These gates form a loop: specify, constrain, verify, review, observe. A failure at any gate sends the change back with a small, actionable error, not an invitation to rewrite the whole repository. That idea leads directly to write an executable contract. Build a smart support agent sounds clear to a person, but it hides dozens of product decisions. A useful specification names inputs, outputs, forbidden actions, failure behavior, and measurable acceptance criteria. For our app, the input is ticket text and account context, the output is a category, confidence score, and proposed reply. The first safety boundary is explicit: low confidence tickets must be queued for a person, never auto-sent. The second boundary is architectural: the model proposes an action, while application code validates and executes it. Keep durable decisions in versioned files such as spec/triage.yaml, architecture.md, and security.md. The agent can now generate code and tests from the same contract, while reviewers can challenge the requirement before debugging and implementation. Once write an executable contract is clear, make the change small enough to reason about becomes much easier to understand. A production task should say which files may change, which interfaces must remain stable, and what proof is required. That turns improved ticket routing into a bounded change with a visible blast radius. A task file can allow edits under src/triage/, protect billing and authentication, and cap the diff at a reviewable size. The agent should stop when the task exceeds those limits instead of silently expanding scope. Small changes produce clearer tests, more useful reviews, and simpler rollbacks. They also reduce context pollution: the model receives the relevant contract and files, not the entire company codebase. If the requested change cannot fit inside one bounded task, split the specification before splitting the agents. From there, the next practical step is start with one agent, split only for real boundaries. Multiple agents can help, but extra agents also add handoffs, duplicated context, cost, and new failure paths. Start with one coding agent behind the 5 gates, add a role only when its context, tools, or approval rights must differ. A planner may read requirements and create tasks without changing source code. A builder may edit an allowed module but cannot merge or deploy. A verifier runs tests in a clean environment and reports evidence without repairing its own failures. A reviewer receives the spec, patch, test results, and risk summary, then decides whether the change can advance. Pass structured artifacts between roles, task IDs, patch references, and test reports, not free-form stories that can drift. This sets up the next important point: treat every tool as a capability. An agent becomes operationally powerful when it can read files, execute commands, call APIs, or modify customer data. Tool descriptions are not security controls, permissions must be enforced by the host application outside the model. Give each tool a narrow schema, validate every argument, and return only the data needed for the next decision. Default to read-only access, require explicit approval for writes, and block destructive operations from autonomous execution. In our example, getTicket may read one ticket, while updateTicket requires a validated ticket ID, an allowed status, and a human approval token. An MCP-style tool interface can standardize discovery and invocation, but the server still needs authentication, authorization, validation, and audit logs. Treat tool output as untrusted input too. A ticket, web page, or repository comment can contain instructions designed to redirect the agent. With treat every tool as a capability in mind, the next piece is run generated code in a sandbox. A safe workflow does not execute a new patch on a developer laptop with production credentials. Run it in an isolated, disposable environment with a non-root user, read-only source where possible, strict resource limits, and no production network route. Inject short-lived test credentials at runtime, never paste secrets into prompts or commit them to the repository. Pin dependencies and scan the resolved lock file, because an agent can choose a plausible package name that is malicious or simply incorrect. Deny outbound network access by default, then allow only the exact test services the task requires. Capture commands, tool calls, changed files, and exit codes so the run can be reconstructed later. Destroy the environment after the evidence is collected. Persistence belongs in approved artifacts, not in the sandbox. That idea leads directly to make correctness deterministic where you can. Unit tests should lock down pure business rules before an evaluation asks whether the agent seems helpful. For ticket triage, confidence below 0.80 must always produce human_review, regardless of the wording of the draft. Contract tests verify that the model adapter returns the expected schema and that tool arguments are rejected when malformed. Integration tests use fake help desk and model services, so CI stays repeatable and does not change real customer data. Include failure cases, timeouts, missing account context, malicious ticket text, invalid JSON, and duplicate requests. Run tests in a clean environment and publish machine-readable results next to the patch. A failing invariant blocks the change. The agent cannot talk its way around a red test. With make correctness deterministic where you can in mind, the next piece is evaluate behavior, not just compilation. A green unit test suite can still hide an assistant that routes urgent tickets incorrectly or drafts unsafe replies. Build an evaluation set from representative, edge case, and adversarial tickets with expected outcomes. Score dimensions separately: routing accuracy, escalation recall, groundedness, policy compliance, latency, and cost. Keep a frozen regression set for release gates and a rotating exploration set for discovering new failures. Compare the candidate to the currently deployed version. A raw score is less useful than knowing what improved and what regressed. Allow only a small number of repair attempts, and feed the agent the failed case plus the relevant contract, not the hidden expected answer. If the budget is exhausted, stop and escalate instead of creating an infinite self-fixing loop. That idea leads directly to observe the decision path. Production telemetry should connect a user request to the model call, tool request, policy decision, external side effect, and final response. Record correlation IDs, model and prompt versions, tool names, latency, token usage, validation results, and approval events. Do not log raw secrets or unnecessary customer text. Observability must respect the same data boundaries as the product. Alert on operational signals such as repeated tool denials, unusual write volume, evaluation drift, cost spikes, and rising human escalations. Preserve the deployed artifact, configuration, and migration version so rollback is an executable action rather than a vague plan. Start with a canary or shadow run when a change can affect customers, then expand only after its evidence matches expectations. The trace should answer 3 questions: what did the agent see, what did it request, and what did trusted code actually do? This sets up the next important point: make human review evidence-based. Human review is not a ceremonial click after the agent declares success. The pull request should summarize the requirement, affected components, security impact, test evidence, evaluation deltas, and rollback plan. Protected branches can require passing status checks and an approving reviewer before merge. High-risk actions, production rights, permission changes, migrations, and secret access need explicit approval at the moment of action. Reviewers should inspect the contract and the behavioral diff, not only whether the generated code looks polished. The agent may suggest a fix after review feedback, but it should produce a new patch and fresh evidence. Approval ownership remains with a named person or team. The builder cannot approve its own production change. From there, the next practical step is the production-ready definition of done. A production AI change begins with a version specification and measurable acceptance criteria. Its task is small, its editable surface is bounded, and every agent role has only the capabilities it needs. New code executes in isolation with short-lived credentials, validated dependencies, and restricted networking. Deterministic tests guard invariants. Behavioral evaluations measure quality, safety, latency, and cost. A trace explains every meaningful decision and side effect, while the release retains a tested rollback path. Protected review gates merge and deployment, with explicit approval for high-risk operations. You do not need every control on day one. Add the spec, one bounded tool policy, one regression suite, and one visible release gate first. To wrap up, here is the key takeaway. You now have a structured overview of Vibe engineering. Build production-ready apps with AI agents. Review the core ideas, connect them to examples, and revisit concepts like the prototype is not the product, the 5-gate production loop. Write an executable contract when practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.